In the world of blockchain, you've probably heard the big promise, right? Code is law. It's supposed to be set in stone forever. But what happens when that law is wrong? Today, we're going to dive into that fascinating paradox, the huge clash between permanence and the very real need to evolve. And that's the idea that got everyone so excited in the first place. Once a smart contract is out there, on the chain, its rules are absolute. They're unchangeable. The network itself enforces them. It's this powerful vision of, trustless, totally automated agreements. And right there, that's the multi-billion-dollar question. What if that perfect, unchangeable code has a massive flaw, a vulnerability? Or what if the world just moves on and the code desperately needs to adapt? This is where that simple, elegant idea of code is law comes crashing into messy, complicated reality. So first, let's really dig into this core principle of permanent code, just to understand exactly why it creates such a crazy paradox. Okay, so this is what we mean by immutability. Once that code is on the blockchain, you can't just go back and hit edit. The functions, the rules, all the business logic, it is locked in. Now, to be clear, the state of the contract, things like account balances, that can change all the time. But the actual code that controls how those things change, nope, that's set in stone. And this immutability, which sounds so great for security and trust, can flip on a dime and become a massive liability. It can become a permanent problem. And the reasons for wanting to change it are super practical. I mean, think about it. A huge, crippling bug could be found after it's deployed, putting millions of dollars on the line. Or maybe the team needs to add new features just to stay competitive. Or, hey, what if regulations change and the contract has to be updated to be compliant? The real world is constantly changing, and good software, well, it has to be able to change with it. So in the early days, the only real solution was, well, it was a mess. You had to deploy a completely new contract and then somehow convince your entire user base to manually move all their stuff over. This process, which people started calling a social yeet, was just chaotic. It was expensive and it depended entirely on everyone cooperating. There had to be a better way, right? And thankfully, there is. Meet the proxy pattern. Now, this isn't some magic that lets you edit unchangeable code. Instead, it's a brilliantly clever design that lets you work around it. So the big idea here is actually pretty simple, but it's genius. The proxy pattern does one really powerful thing. It separates the parts of a contract that need to stay permanent, like its address and all the data it's storing, from the part that might need to change, the actual logic. The absolute best way to wrap your head around this is the P.O. box analogy. It's perfect. Think of the proxy contract as your permanent P.O. box. Everyone has this address, and it will never, ever change. The implementation contract, that's the actual house where you live. Now, let's say you decide to move to a new, better house. That's like your new version of the code. You don't have to go tell everyone your new home address. You just tell the post office, hey, forward my mail. Your P.O. box address stays exactly the same for the rest of the world. So in tech terms, we've got a few key players in this little drama. You've got the proxy, that's our permanent P.O. box that holds all the data. You have the implementation, which has the actual code that we can swap out. You've got the user, who only ever talks to the proxy's address. And then, and this is crucial, you have the admin, a special account that has the power to tell the proxy which implementation to point to. Okay, so the P.O. box thing makes sense conceptually. But how does this actually work under the hood? Let's take a look at the technical magic that makes this whole thing possible. The entire system hinges on one special, kind of weird function called delegate call. And here's the most important part. It lets the proxy contract basically borrow the code from the implementation contract. So the logic from the implementation runs, but it operates on the data that's stored inside the proxy. The code comes from one place, but the data it changes lives in another. It's a game changer. And this visual right here shows you exactly why this is so different. Up top, you've got a normal call. Contract A calls contract B, and any changes happen to the data inside contract B. Simple enough. But look at the bottom with delegate call. Contract A calls contract B, but the code from B actually modifies the data inside contract A. B is just lending its logic to A. That is the core mechanic. All right, so let's walk through a transaction from start to finish. Imagine you're a user. You want to interact with this app. You don't know and you don't care about some implementation contract. You just send your transaction to the one public address you know, the proxy contract. So here's what happens next behind the scenes. The proxy contract itself doesn't actually have the function the user called, so a special fallback function kicks in. This function grabs the user's request and uses delegate call to forward it over to the current implementation address. The implementation's code runs, but remember, because it's a delegate call, it's modifying the data stored back inside the proxy. And finally, the result gets passed all the way back to the user, who has no idea all this fancy redirection just happened. And now for the magic of the upgrade. This is the whole point, right? The admin deploys a new version of the logic. Let's call it implementation v2. Then they just call a special function on the proxy to simply change which address it points to. And that's it. All the important stuff, all the user balances, the entire state of the application, it all stays safe and sound, untouched inside the proxy. The very next user transaction just gets forwarded to the new logic. It is an incredibly slick solution. But, and this is a huge but, all this elegance, all this flexibility, it comes at a cost. And it's a cost that really strikes at the very heart of decentralization itself. And this quote right here, it brings us to the core of the whole debate. If a team can change the logic whenever they want, then that guarantee that code is law is, well, it's gone. Can you still call it a truly trustless, decentralized system? So here's the core trade-off laid bare. On one side, you have pure immutability. It's fully decentralized, totally trustless, but it's also rigid and completely unforgiving if you make a mistake. On the other side, you have upgradability. It's flexible, you can fix bugs, you can add features, but it introduces a central point of control. It forces you to trust that the admin is always going to do the right thing. And this isn't just theory, it introduces very real new risks. A malicious or maybe even a compromised admin could deploy code that just steals everybody's funds. The proxy pattern itself is complex, which adds another layer where bugs can hide. And maybe the most subtle risk, it can create this hidden centralization where a project looks and feels decentralized, but really a single person or a small group holds the keys to change the rules at any time. And beyond the whole philosophical debate, the technical side is absolutely full of pitfalls. Getting proxies right involves some incredibly subtle, low-level coding. There are all these complex issues around things like data storage and how transactions are handled that are just so easy to mess up. And like the slide says, a single mistake doesn't just create a bug, it can permanently break your contract or, way worse, let an attacker hijack it completely. The stakes could not be higher. So this leaves us with a really fundamental question. Is upgradability just a necessary evolution for building apps that can survive in the real world? Or does the central trust it requires just completely undermine the very principles that made this technology so revolutionary in the first place? Honestly, there is no easy answer here, and this exact debate is shaping the future of the entire decentralized web as we speak.